Hello and welcome to SudoKanard. We're here to solve this two-digit prime number Sudoku by Italian author Valeria Losasso in the recent WPF Sudoku Grand Prix. So we're doing lots of puzzles by Valeria, but there are also other Italian authors and we will meet them on subsequent videos. So the special rule here is that every time you have a horizontal or vertical lines, it means that the corresponding digits form a two-digit prime number, and the list is given on your screen. And very importantly, all possible lines are given. You can see that 52 is not a prime number, nor is 39, which is divisible by 3. And so that's it. So something very important to note is that every unit digit can only be 1, 3, 7, or 9. So those unit digits here are not 9s. Actually, this here can only be 1 or 3. This can only be 1, 3, or 7. This can only be 1, 3, or 7. This can only be from 3, 7, 9. This can only be from 3 and 7. And those are also unit digits, different from 9, so they must be from 1, 3, 7. And here we get a 1, 3, 7 triple. And we can see that on this column, 6 can only be here. 63 is not a prime number. 61 and 67 are. And this here is 5, and then 57 is not a prime number, it's divisible by 5, so that's 53, which is a prime number. And here all options will work. 61, 67, 17, and 71 are all prime numbers, so we can't do anything more here, but I can rule these 3 out of this cell. This here is also a unit digit for a prime number, so it's from 1, 3, and 7. Those here are unit digits, so they are a 1, 3, 7 triple. That's not 7, that's not 1. And the remaining cells here must be 4 and 6. And because of this 4, that's a 6, that's a 4. This is a unit digit. And actually all options are valid, and by that I mean that all 3 numbers, 41, 43, and 47, are prime numbers. This is a unit digit, and both options here, 37 and 97, are both prime numbers. Here I still have 4 candidates. I don't feel like pencil marking it. This is 3 or 9. Here, all 4 options are still possible, so I won't pencil mark that, but this 8 now goes here. 81 and 87 are both divisible by 3, so that can only be a 3. Here those are from 1, 7, and 9. And there is a 9 among them. Now here we have 2, 5, 2, 4, 5, and 6. There's a 4 here, a 6 there, so this is from 2, 5. This is from 2, 5, 6. This is from 2, 4, 5. Not much can be done at this point. Not much more, actually. So what are the prime numbers ending with a 9? Well, there's 19, but 1 is not available. There's 29. 3, 4, 59 works. 69 is not a prime number. 79 is. 89 is as well, but 8 is not available. Those are also unit digits, and there must be a 1, 3, 7, 9 triple. This is not 1 or 3 because of that. This is not 1 or 9, and it's not 7 either, so that's a 3. That's a 9, that's a 3, that's a 7. So that's not a 3. That can only be a 1 because of all of those. And here that's not a 7. So that can be done at this point. This is from 1, 3, and 7. Oh, here, what are the options? So just by the rules of Sudoku, the options are 5, 6, and 7. But 51 is not a prime number, and 7 is actually not available. So that's a 6. This 5 here goes there by the rules of Sudoku and removes this option. Here we need 4, 7, and 8. 4 and 7 are here, so that's 8. And those are a 4, 7 pair, so we can remove 7 from some of the candidate lists. On this row, I still need 9 and 2. 9 goes here, 2 goes there. And there, 27 is not a prime number, so that's 29, which is a prime number. That's a 7, that's a 9. That's not a 9. And 9 in this box goes here. 69 is not a prime number, it's divisible by 3, but 29 and 59 are prime numbers. Now this is a 2-5 pair, so that's a 4. Both options here are prime numbers, and this now can only be a 6. And 67 is indeed a prime number. And this row needs 1, 3, and 5, so this is 5, and that works. That's 1 or 3. And here, none of those options, 91 and 93, are prime numbers, so the lack of a line here is completely good. There's a 3 here, actually. So some of those ambiguities are just resolved. So what next? Here both numbers must be prime. With 2 it doesn't work. Both are non-prime. 41 and 47 both work. 8 is not available. 61 and 67 both work. So all those are valid options. Here, so the digits here are 2, 4, 5, and 6. 6 is not in here. 8 is not here. So this is 2 or 4, but 49 is divisible by 7. This is from 4, 8. And this is from 4, 6, and 8. But 64 is not prime. 63, sorry. And this is finally a 6. Next place to look, this is a 2. There's already a 7 on this row. And we complete the row with a 5. This 4-8 pair makes this a 7. That's a 4. And we complete this column with a 7. 73 is prime indeed. That's a 6. So what do we need here? We still need a 4 somewhere, but there's a 4 here. So that's a 4. 5 is not here, so on this column 5 is here. That's a 2. And that's also a 2. 23 is prime indeed. Indeed. Here I need 4, 5, and 8. So this can only be a 5, and 59 is prime. That's a 4-8 pair. And that's interesting because here we seemingly get a deadly pattern. But actually, 47 is a prime number, so 4 doesn't work here because there's no line. But 87 is not a prime number, so this is 8, this is 4. Finally, we use the negative rule. That can only be a 9. Here we need 4 and 8, but there's an 8 here. Here I need 5 and 7, but there's a 5 here. And actually, 51 is not a prime number, so There was no ambiguity. Up there on this row, we still need a 4 on this column, actually. This is from 1, 3, and 7. And what's interesting is that all possibilities here work. So, well, actually, this is a 7. But what I meant by that is that all the two-digit numbers with two different numbers from 1, 3, and 7 are prime numbers. Here, that's the 7, that's the 2, and that's the 5, and 51 is not a prime number. It's divisible by 3, so that's the 3, and that is the final disambiguation. So the negative rule wasn't that useful, but it was necessary at this stage of the solve. So that was a very non-struggling puzzle. And that is if you're fluent in prime numbers, which I think I am, at least for two-digit prime numbers. This is very much my culture. And it can definitely be more difficult if you're not used to the exact list of prime numbers. And it's a very good idea from the organizers to put the list of two-digit prime numbers on the puzzle booklet. I think that was a very kind attention to people who happen not to be fluent with those. Thanks for watching this video and see you soon on SudoKanard.